Hey everyone, welcome back to the P3 series. So in the last video, we talked about secant, cosecant, and cotangent reciprocal functions. Today, we are going to talk about compound angle identities or angle addition identities. So a common mistake beginner students make is when we have something like this, they expand it as sine A plus sine B, which is obviously not correct because sine theta is a function. It's not a variable or it's not a pronumeral, it's not a number, it's a function. The angle inside is a parameter of that function. So we cannot expand it like this. Instead, what we do is that when we have this sine A plus B, it can be expanded as sine A times by cos of B plus cos of A times by sine of B. And if the sign in the middle is negative, we will have negative sign in the middle on the right side also. Similarly, when we have cosine A plus B, this goes like cos of A times by cos of B, negative sine of A sine of B. And if the sign in the middle is negative, we will have the opposite sign on the other side of the identity. Finally, let's look at tan A plus B. So this expands with tan A plus tan B whole divided by 1 minus tan A tan B. And once again, if the sign in the middle is negative, we will have negative and positive on the opposite side. Now, this is when two angles are different. What if the two angles are the same? So, for example, when we have sine of A plus A, this would be same as saying that this is sine of 2A. Now we will expand it in a similar manner. Sine A times by cos of B. This time it is A, so sine of A, cos of A. Sine in the middle is positive. Then cosine of A, sine of A. These two terms are identical to each other. So this becomes 2 sine A cos of A. Now, when we are dealing with this type of situation, these are double angles. So we refer to them as double angle identities. Similarly, let's tackle the cosine. Cos 2A. Similarly, that could be written as A plus A also. So cos of A times by cos of A again. Sign in the middle should be negative because it's A plus A. Sine A, sine A. This means cos squared A minus sine squared A. Now this is one variation of this. So this is one form of cos A. Why? Because we know that cos squared A plus sine squared A is identical to 1. So if we do not have one or the other, we can represent the same information in the form of the other one. So for example, if cos information is not available, we can write it in form of sine. So sine squared A is 1 minus cos squared A, and cos squared A is identical to 1 minus sine squared A. Now let's rewrite this thing in the form of one or the other. So if I have cos squared A minus sine squared A, and I want to substitute for the sine, this thing. So this would become cos squared A minus 1 minus cos squared A. This expands to cos squared A minus 1 plus cos squared A. This becomes 2 cos squared A minus 1. This is the second variation of cos 2A. Similarly, we could do the same thing by substituting cos squared A also. So 1 minus sine squared A minus sine squared A. This simplifies to 1 minus 2 sine squared A. Now, all of these are different variations of cos 2A. Now, let's look at tan 2A. So same way, we have tan A plus tan A, 1 minus tan A times by tan A. So this becomes 2 tan of A, 1 minus tan squared A. So this is the expansion for tan. Now, how do we use these in equations or identities or problems? Let's look at a few questions to understand what we can do. Look at this example. Solve the equation tan x plus 45 is equal to 2 cot x. So first off, we need to expand the left-hand side. So tan x plus 45, we expand it as tan x plus tan of 45 divided by 1 minus tan x tan 45. Now tan of 45 is equal to 1. So this simplifies to tan of x plus 1 minus tan of x. You could also write it as 1 plus tan x and 1 minus tan x. The right-hand side is a cot, so we can turn it into 1 over tan. So this becomes 1 plus tan x over 1 minus tan x equals to 2 over tan x. Next step would be cross multiplication. Tan x plus tan squared x. So basically what we're doing is we are cross multiplying. Equals to 2 minus 2 tan x. Now we take everything on one side. Tan squared x. 1 plus 2, that would be 3 tan x, minus 2 equal to 0. Now this is a quadratic equation in tan. So what we need to do is we need to find solutions for this. So what we can do over here, so I'll use a different variable for that. So a squared minus 2 and 3, positive 3. So I have this. So as you can see, there is no, since 2 is a prime number, there's no way we can adjust 2 and 1 to get 3a positive, because one of them has to be negative. So we have to go through the quadratic formula over here. So tan x would be equal to minus 3 plus minus b squared minus 4ac, 4 times by 2, 8, divided by 2 times by 2. So minus 3 plus minus 9 plus 8 is 17, divided by 2. So we know that since we're looking for values in 0 to 180, tan is positive in this region and negative in this region. So we have to look for both positive and negative values. So tan x is either minus 3 minus root 17 over 2, and it could be just as well minus 3 plus root 17 over 2. Now let's look at in the calculator. So tan inverse of minus 3 minus root 17 divided by 2, we get minus 74.3, 165, let's say. And the other one is going to be 29.3165. Now, tan has periodicity of 180 degrees. So this is plus minus 81n, and this is also plus minus 180 degrees times by n, where n would be any integer. Or you could also write it as n is equal to 0, 1, 2, and 3, so on. Now, one of the answers is acceptable for us, 29, that is acceptable to us, but minus 74 isn't. So we subtract, do this answer plus 180, we get 105. So 105.68 or just 7 degrees. If we go further, 180 degrees, that will be beyond the range. And similarly, this one would be 29 as it is. So this and 29.3 would be the answer. So actually, you would write it in ascending order, 29.3 degrees and 105.7 degrees. Right, let's look at another example. Now, let's look at this. The angles alpha and beta lie between 0 and 180 degrees and are such that when tan of alpha plus beta, that is equal to 2, and tan of alpha is equal to 3 times by tan beta. So this is a sort of like simultaneous equations because we have two conditions, two unknowns, but not the same linear simultaneous equations, non-linear ones. So let's expand this, the first one. So tan alpha plus beta equals to 2. So when we expand this, we get tan alpha plus tan of beta divided by 1 minus tan alpha tan beta equals to 2. Now, since we have tan alpha is equal to 3 tan beta, so what we do, we replace tan alpha with this. Since tan alpha is equal to 3 tan of beta, so we replace every instance of tan alpha with tan beta, 3 tan beta. So 3 tan of beta plus tan of beta divided by 1 minus 3 tan of beta times by tan of beta equals to 2. This simplifies to 4 tan of beta equals to 2 times by 1 minus 3 tan squared of beta. So further simplification, 2 minus 6 tan squared of beta. Now we take everything on one side. 6 tan squared beta plus 4 tan beta minus 2 equal to 0. Since all the coefficients are divisible by 2, 3 tan squared beta plus 2 tan beta minus 1 equal to 0. Now let's see if we can factorize this. So 3x squared minus 1, 2x. 3 is a prime number, 1 is also a prime number. So 3x and x, yes, it can give us 2x if we keep this one negative. So we have 3 tan beta minus 1 and tan beta plus 1 equal to 0. So this means that either tan beta is 1 over 3 or tan beta is minus 1. Now, if this is the case for tan beta, remember tan alpha is 3 times by tan beta. So we could actually go for that also. So tan alpha would be 3 tan beta. So 3 times by 1 over 3 is 1. And 3 times by tan alpha would be 3 times by negative 1, so minus 3. Now first let's solve for tan beta. Tan beta equals to 1 over 3 tan L beta minus 1 tan alpha 1 and tan alpha negative 3. Now when tan of beta is 1 over 3, so tan inverse of 1 divided by 3, 18 plus 4, 3, 4, 9. And plus 180 plus minus 180 degrees n. We will write the condition for n in a second. Similarly, minus 1, so tan is minus 1 at minus 45 degrees. So minus 45 degrees plus minus 180 degrees n. Tan is 1 at 45 degrees. So 45 degrees plus minus 180 degrees n. And tan alpha negative 3 or 3 is 71. So tan is negative in the second quadrant at this place. So 71 would be this. but 180 minus this value would be 108. Sorry, 108.4349 plus minus 180 degrees n. Now, we need to see which of the values are in our region. Sorry, the question was that we need to go between 0 and 180 degrees. Okay, now let's look at the possible solutions now. So one answer, 18.4, is fine for us. But it's possible that when we do minus 180, obviously when we do the minus 180, it will go beyond the range. So we don't need that. This one, on the other hand, so minus 45 plus 180, when we do minus 45 plus 180 will give us 135. So that is an acceptable solution. Now, for the alpha, 45 is an acceptable solution already for us. If we go plus 180 and minus 180, that's out of the required range. Similarly, 108.4, that is an acceptable solution. If we go plus or minus 180, it goes beyond the range. So 108.4 degrees. And that's our final answer. Now let's see another example. Let's see this. Part A, given that cos x minus 30 is equal to 2 sine x plus 30, show that tan x is equal to this expression. Okay, so let's see this. So when we expand cos x minus 30 degrees, it expands to cos of x times by cos of 30 degrees plus the sign in the middle is opposite, sine of x times by sine of 30 degrees. Now cos of 30 is under root 3 by 2 plus sine of x. Sine of 30 is 1 over 2. So this simplifies to root 3 over 2 cos of x plus 1 over 2 sine of x. Now let's see the other side. We have 2 sine of x plus 30. So 2 square brackets sine x sine of 30 plus, sorry, no, that's cos of 30. Sine of 30 cos of x. Now this expands to cos of 30, again, is root 3 over 2. Sine of 30 is 1 over 2. So 2 sine of x root 3 over 2 plus 2, 1 over 2 cos of x. Now we cancel out this 2 with this 2, this 2 with this 2. So this simplifies to root 3 sine of x plus cos of x. Now these two expressions are equal to each other, so we will equate them. Root 3, therefore, root 3 over 2 cos of x plus 1 over 2 sine of x equals to root 3 sine of x plus cos of x. Now we bring all the sine terms on one side, cosine terms on the other. So half sine x minus root 3 sine x equals to cos of x minus root 3 over 2 cos of x. We factorize out sine x and cos x. So sine x half minus root 3 equals to cos of x 1 minus root 3 over 2. What we can do is we can make the denominators the same. Sine x 1 minus 2 root 3 over 2 equals to cos of x 2 minus root 3 over 2. Now, since these two are factors, we can cancel out this 2 with this 2. Now, we bring cos of x on the left side and the coefficient of sine x on the other side. 2 minus root 3 divided by 1 minus 2 root 3. Now, let's hope it was the same expression. 2 minus root 3 and 1 minus 2 root 3. Yes, exactly that. Hence, solve the equation, this, for x 0 to 360. So if we want to solve this equation, we need to solve this equation. So, I forgot. Therefore, this is equal to tan x equals to 2 minus root 3, 1 minus 2 root over 3, since tan x is equal to sine x over cos x. So this is the final thing for part A. Now let's solve this for part B. So tan inverse of 2 minus root 3, 1 minus 2 root 3. We get minus 6.2. Oh, sorry. Tan inverse of 2 minus root 3, 1 minus 2 root 3. We get minus 6.2060. And we know that tan's periodicity is 180 degrees. 180 degrees n, where n is 0, 1, 2, and so on. Now, the range of values of x we were given is from 0 to 360, not before or after. Now, for the solutions of x, minus 6.2 itself isn't acceptable, but we can add 180 once or twice to get that into the range. So minus 6.206 plus 180 degrees and minus 6.206 plus 180 times by 2. Basically following this rule over here. So minus 6, so wait, this plus 180 is 173 minus 1, positive 173.8, and one more 353.8. These are our final answers. Now, let's look at another example. Prove the identity cos 4 theta plus 4 cos 2 theta plus 3 is identical to 8 cos raised to power 4 theta. Now, what you need to see over here is that we have one ratio with angle 4 theta, another ratio with 2 theta, and on the right hand side we have theta alone. So the double angle and the 4 times by that angle. All right, so let's look at another example. Prove the identity cos 4 theta plus 4 cos 2 theta plus 3 is identical to 8 cos raised to power 4 theta. Now what you need to notice over here is that we have theta on the right hand side, but on the left hand side we have a double angle and we have a quadruple angle also. So that means on the left hand side we need to convert this 4 theta into theta and 2 theta into theta also. Like we need to re-express the left hand side in the form of ratios that only have theta, not 2 theta, not 3 theta, not 4 theta. So let's see. So the way we can handle it is by dealing with cos 4 theta and cos 2 theta separately. And then we turn the left hand side. So we know that cos 2 theta can be written as cos squared theta minus sine squared theta, or it could be written as 2 cos squared theta minus 1. It could be also be written as 1 minus 2 sine squared theta. Now, since we have to go into the cosine, let's select this one. Similarly, cos 4 theta, we can select it according to this one. So half of 4 theta would be 2 theta minus 1. And then finally, we would expand cos 2 theta with this expansion further. So 2 times by cosine of 2 theta whole squared, 2 cos squared theta minus 1 whole squared minus 1. So this is a square, so let's expand the square. So 2 times by 4 cos raised to power 4 theta minus 4 cos squared theta minus plus 1 and minus 1. So when we expand it, 8 cos raised to power 4 theta minus 8 cos squared theta plus 2 minus 1. Now we somehow need to figure out a way to add these together. So cosine 4 theta plus, so left hand side, 4 cos 2 theta plus 3 will be identical to this, 8 cos raised to power 4 theta minus 8 cos square theta plus 2 minus 1, basically just 1. Now plus 4 times by cos 2 theta will be this. 4 times by 2 cos square theta minus 1 would be 8 cos square theta minus 4. So 8 cos square theta minus 4 plus 3. And as we can see this over here, minus 8 cos squared plus 8 cos squared, they will cancel out. We are left with 8 cos raised to power 4 theta plus 1 minus 4 plus 3, they also cancel out. So we are left with 8 cos raised to power 4 theta. So therefore, left hand side is identical to right hand side. All right. Hence, solve the equation equals to 4. Now, we need to see what's the connection between this and the given in what's given in the question part B. We expanded cos 4 theta plus 4 cos theta plus 3. We need to see how this is related to that. So cos 4 theta plus 4 cos 2 theta plus 3, if this is equal to 8 cos raised to power 4 theta. Now we need to see what is this equal to, or how to get rid of 3 and put 4 on the other side. So we take this on the other side, 3 on the other side, 4 cos 2 theta, 8 cos raised to power 4 theta minus 3. And this is what they're saying, that this is equal to, 4. So this is exactly what we will do. So this is hence 8 cos raised to power 4 theta minus 3 is equal to 4. This is what we have to solve. So first off, we rearrange for cos raised to power 4 theta, 4 plus 3, 7 over 8. Then we take the square root. Cos squared theta is equal to plus minus root 7 over 8. Now, obviously, we cannot take the square root of the negative square root of 7 over 8. We can only do that for the positive one. So cosine of theta will be equal to 7 over 8 raised to power 1 over 4, because we're taking the square root of the square root, and plus minus. So basically what we're saying is that we cannot take the square root of a negative number. We can only take the square root of a negative number. But once we do that again, another step, we will have a plus minus situation. So it would be better if we write it separately. Cos theta is equal to minus 7 over 8, 1 over 4. Now, since we have the same angle, but in different quadrants, one is positive, one is negative. So cos inverse 7, over 8 raised to power 1 over 4, 0.25. We get this. So using the cos diagram, cosine is positive in the first and the fourth quadrant. So this is 14.7 over here, 14.7 over here. The negative will have the same angle with the x-axis, but obviously from the positive x-axis, it will be different. So since we are asked for angles in between 0 to 180 degrees, so we will only select 14.7 and 180 minus 14.7. So theta will be 14.7 degrees and 180 minus 14.7 degrees, which would be 165.3 degrees. Now let's look at another example. Solve the equation 2 cot 2x plus 3 cot x equals to 5. So we know that cot of x is 1 over tan x. Similarly, cot of 2x would be 1 over tan 2x. So double angle, basically. So we know that tan of 2x can be written as 2 tan x over 1 minus tan squared x. So that would mean that the reciprocal will be written as 1 minus tan squared x over 2 tan x. So now when we add these terms together, 2 cot 2x plus 3 cot x, we need to find the equivalent expression. 2 cot 2x would be 2 times by 1 minus tan squared x over 2 tan x plus 3 times by cot x, which is going to be this, 3 over tan x. Now this 2 and this 2 can get cancelled. So we have a common denominator over here. So this simplifies to 1 plus 3, 4 minus tan squared x over tan x. This is now equal to 5. So 4 minus tan squared x over tan x is equal to 5. Now we cross multiply. This becomes 4 minus tan squared x equals to 5 tan x. Now this is a quadratic equation. We bring everything on one side. So tan squared x plus 5 tan x minus 4 equal to 0. Now there is no combination of 4 to make a product of 4. We can have 2, 2, we can have 4, 1, where we get a negative 4 and the sum is coming out to be positive 5. So we need to do this with the quadratic formula. So tan x would be equal to b minus b plus minus b squared 4ac. So 4 times by 4, 16 plus 16 divided by 2. So minus 5 plus minus 25 plus 16, that is 41 divided by 2. So two values of tan x that we have are minus 5 plus root 41 divided by 2, and the other value is minus 5 minus root 41 over 2. Now, we are looking for 0 to 180 degrees. So we are looking for the angles in first two quadrants. So let's copy this over here also. We'll just keep it down here so we can see the angles. Right. So when we plug this in, so tan inverse of minus 5 plus root 41 divided by 2, 35. So one angle is 35.05 degrees. And we don't want it, so tan is also positive in the third quadrant, but we don't want the third quadrant. We only need the first quadrant. Now the negative, tan is negative in the second quadrant. So minus 80. Oh, sorry. Minus 80 means that this is over here, 80 degrees. So that would mean that when we do the plus 180, so we would have somewhere over here. So this is also 80.05, 80.05. So the angle that we would have is 180 minus this. Now, so the final angles that we have are x is equal to 35.05 or just 35.1 degrees. And the other would be 180, sorry, we just need to do plus 180, 99.4, sorry, 947.8. So we round it to 99.9 degrees. So that will be our final answer. Look at this example. Prove that 1 minus cos 2 theta over 1 plus cos 2 theta is identical to tan squared theta. So what we do over here is we need to first think about what to use for cos 2 theta. Because we have three different versions of cos 2 theta, two different variants. So we have cos squared theta minus sine squared theta. We have 2 cos squared theta minus 1. And we also have 1 minus 2 sine squared theta. So we cannot just use them randomly. We need to see how tan squared can be formed. So tan squared can be formed by having a sine squared theta and cos squared theta add in numerator and denominator respectively. So for the numerator, 1 minus cos 2 theta, we need to choose the one with the sine. And then for the denominator, we will choose the one with the cosine. So 1 minus cos 2 theta, 1 minus, we will choose the sine one, 1 minus 2 sine squared theta. So this 1 and 1 will cancel out, so we are left with just 2 sine squared theta. Similarly, 1 plus cos 2 theta. Similarly, this time we will choose the cosine one, so 1 plus 2 cos squared theta minus 1. Again, 1 and minus 1 cancel. We are left with 2 cos squared theta. So now, when we put these two in numerator and denominator, this is equal to 2 sine squared theta over 2 cos squared theta. And as you can see, 2 and 2 get cancelled, leaving us with just sine squared over cos squared, which is identical to tan squared theta. So therefore, left-hand side is identical to right-hand side. Now, let's look at one last example. By first expanding sine 2x plus x, show that sine 3x can be written as 3 sine x, 4 sine cube x. Now, if you notice, we have sine 3x over here and 2x and x over here, but on the other side, the angles are all x. So that means we are reducing 2x plus x further into just single value of x. So let's see how do we do that. So for sine 3x, obviously that means we can expand it as sine 2x plus x. We will use the compound angle identity for sine. That will have sine 2x cosine of x plus cosine of 2x sine of x. Sine 2x we know can be written as 2 sine x cos of x. However, cos 2 of x, cos 2x can be written three ways. Cos squared x minus sine squared x. We can have 2 cos squared x minus 1 and 1 minus 2 sine squared x. So we need to be very careful with which variant we use over here. So sine 2x times by cos of x plus cos 2x times by sine of x. Let's rewrite it. Sine 2x is 2 sine x cos x times by cos x. So that becomes 2 sine x cos squared x. Now, plus this one. Again, we have sine x times by something. So let's use this one. So sine x times by 1 minus 2 sine squared x. So we can have 2 sine x. Again, we can split this into 1 minus sine squared also. Plus sine x minus 2 sine cubed of x. So now we expand the bracket on the first term. 2 sine x minus 2 sine cubed of x plus sine of x minus 2 sine cubed of x. So sine x terms turn up, can be added and will make 3 sine x, and minus 2 sine cubed minus 2 sine cubed make minus 4 sine cubed of x. Now let's see if this is the same thing that they wanted. Yes, exactly as what they wanted. So over here, we used two expansions. We used the double angle identity for sine also and for the cosine also. All right, so we have done the double angle identities for sine, for cosine, and for tan also, and for cot also. So hopefully we will see each other again in the next video. Subscribe to our channel, like this video, and if you feel that I have made a mistake somewhere or left out something important, please don't hesitate to comment. So bye bye, see you soon.